Hey guys, this is Miss V. It is Thursday. We are moving on to topic 8.8b, which is the student is expected to write a corresponding real-world problem when given a one-variable equation with variables on both sides of the equal sign. All right, so guys, the only difference here is now instead of writing the equation from a word problem, here we're going to be given the equation and asked to either match it to the word problem or write our own word problem. So again, let's just go over a few vocabulary parts of the equation, things that we need to know. Again, our equation splits right down the middle, and it gives us these two expressions, one on the right side and one on the left side. All right, and then again, we have our coefficients, we have our variables. Again, a variable is a letter that represents some number. We have our constants, which are numbers that stand alone in an equation or an expression. And same thing on the right side. Here we got a constant, and we also have a coefficient with a variable. But again, if we were to just continue dragging this line down, we would have two separate equations. This equal sign makes them the same or equivalent, meaning whatever the value is on the left is going to be the same as the value on the right. So again, check out that home screen for the vocabulary flashcards to get more information on parts of an equation. So we're going to have a few quick steps just like 8.8a. We want to identify both parts of the equation, again, the left and the right side. We want to then write that expression in words this time. Okay, last time we were using numbers. And then again, same thing for the event 2 or the right side. We're going to write it in words. And then we're going to combine those two sentences with same as or equal to or equivalent to represent them being equal to one another. All right, so let's move to our first example. Oh, first off, let's talk about vocabulary. Several words could describe all of our operations. So again, these are the main operations that we use when working in math, the four main operations. And then I added equal because there are some words that could describe equal rather than just saying equal to one another. Okay, so let's look at addition. We have words like additional, plus, add, increased, sum, altogether, combine, more than, ascending. Okay, so those are the words that we could use to describe the operation of addition. Subtraction, okay, we got less, decrease, difference, fewer than, take away, deduct, minus, subtract, and descending. Again, words that we could use to describe the operation subtraction than just saying minus or subtract. And same thing again, y'all can go ahead and pause the video if you want to write these down for multiplication and division. All right, so let's move to our first example. Example number 1. X plus 5 is equal to 3x minus 1. So again, we're going to kind of use the same template where we've broken up the equation into two parts, left and right, and we're going to just take it step by step. So let's work with the left side first. We want to represent this x plus 5 in words, and I included the vocabulary so that way it could help you just rewrite things. And the best part about this is I could write this expression one way and use one word to describe addition, but you could use a different word to describe addition and we could be writing about the same expression. So let's look, x plus 5. So several ways we could write this. Again, x is the variable. So again, when we're talking about a variable, we want to either say, we could say a number, okay, to represent that variable. So we could say a number, all right, and then again, now we need to figure out a word to describe addition, and we have this list here, additional, plus, add, increase, sum, altogether. For this simple one, I'm just going to put plus, and then I'm just going to write the word 5. All right, another, we also could have said, since this is addition, we could have said sum. So we could have wrote this as the sum, okay, of a number and 5. Because again, now we're describing a number, which is x, and 5, which is our constant, and we're saying the sum, so that indicates we would be adding them. We could say combine a number and 5, or we could say all together. So again, several ways to write these. Now let's move to the right side. So now we want to focus on expressing 3x minus 1 into words. Now, the 3 and the x, again, are held together by multiplication. We have the coefficient, which is 3, and the x, which is the variable. And again, they're held together by multiplication. So here, we're going to want to look at the multiplication part first to describe the coefficient 3 and the variable together. So we could say times, okay, we could say for each hour or each minute, or multiplying, or the product. But again, for this, we want to just put times because it is a variable. It's not, because we're not talking, we're not talking about the whole thing. So for this one, we could say 3 times a number. All right, then we want to focus on the main operation. The main operation that's holding this term together and this term together is subtraction. All right, so let's see what we can use for subtraction. We got less, decrease, difference, fewer than, take away, deduct, minus, subtract, and descending. All right, so for this simple sentence, 3 times a number, we could say minus, let's just minus 1. Okay, just like with the left side over here, we also could have wrote the difference of, and again, we want to write this part 3 times a number. Oops, again, we're writing in words. My eraser. All right, of 3 times a number. And 1. Okay, we could have also said, let's see, 1 is less than. We could have said, now if we want to use the less than, then we need to put the constant first. So we could have said 1 is less than 3 times a number. All right, so again, several ways we could write these. All right, not everyone is going to come up with the same equation. All right, so then all we do, just like if we were to write the equation, we're just going to use the word is the same as, or other words we could have used equivalent or equal to. So then you just take your statements and you set them equal to one another. So I'm going to erase a couple of these so that way you can just make it nice and pretty so we can see what we're writing. So then we can just put, I'm going to choose this one here, the sum. I'm going to choose this one. So on the left side, I'm going to put the sum of a number and 5 is the same as 3 times a number minus 1. All right. All right. Okay, let's move on to example number 2. All right, so example number 2 is a bit different. All right, so we have, again, we have our equation. So we have our left side over here. We have our left side expression. We have our right side expression. Okay, so I want to focus on the right side first, just because we're going to come back to the fraction part. So this one, 5 plus 3 times a number, or 5 plus 3x. Okay, so several ways we could say that. We could say the sum. We could say 5 plus 3x. We could say 5 added to 3 times a number. So several ways. So I'm going to write the simplest way. 5 plus. Actually, you know what? I'm going to use more than. I'm going to say 5 more than 3 times, again, because the coefficient is 3 times a number. And again, that number is representing the variable right here. Okay. Now, let's now go back to the left side. Let's look at this first term here. X divided by 5. Now again, that means that the answer to a division problem is called a quotient. Okay, so again, we could say fifths, because if we're dividing something into fifths, that means it's 5 parts. Okay, the denominator shows us that. We could say the easiest way, I would say, we could say the ratio of x and 5, because again, a ratio is a fraction. So let's use ratio. I like that one. All right, so the ratio of a number, because that's our variable and we don't know it, a number and 5, okay, because now we're representing our denominator. And again, we're subtracting 2. So we're just going to say the simplest, minus 2. All right. And then we would set those equal to one another in our sentence. So again, the ratio, and instead of rewriting that, guys, I'm just going to draw my arrow. The ratio of a number and 5 minus 2 is the same as 5 more than 3 times a number. All right. Okay, so let's go ahead and move to example 3. This one, I want you to pause the video and give it a try. And again, I've put the vocabulary word bank over here if you need to use it. But again, pause the video, come back and see if you got it right. Okay, guys, so hopefully you worked out example number 3. Again, yours might not be exactly like mine because you might have chosen to use maybe different words to describe the equation, but that's okay. As long as you're using the words from the word bank, we're all good. So the simplest way that I want to see this one, again, we have 2 parts. I'm going to focus on the left side here, 4 times the variable, or 4x. So a simple way to do that, guys, is just 4 times a number. All right, it's plain and simple. Okay, and moving to the right side, we got 5 plus x. So several ways you could have wrote this one. You could have said the sum of 5 and a number. You could have said 5 more than a number, or you could have said 5 or x increased by 5, or anything like that. So I'm going to choose, I'm going to say 5 more than, actually, if I put a number. Again, you also could have wrote the sum of 5 and a number. Even a more simple one, you could have just said 5 plus a number. So several ways you could have wrote that. All right. So again, with this being so broad and people being able to use their vocabulary, it does get a little bit tricky. So our statement at the end should have just been 4 times a number and if you had something close to this, that's great, guys, is the same as, and I'm just going to use a simple one, 5 plus a number. All right. Okay, so even if you didn't have exactly what I'm writing down, that's okay. Okay. All right. Let's move on to how it might look on an assessment or in oops, sorry, wrong button, in word form. Okay, so here's how it might be tested. It says, which situation can be represented by the equation? So in this case, guys, they'll give you the equation and you'll be asked to read each scenario and determine which scenario best matches or goes with the equation being represented. So a nice simple way is for you to maybe write this equation in words yourself, or at least identify the operations. So if we have 7, and I'm going to write it down here, 7x plus 1 is equal to 10x. So let's talk about the left side. What should we see in our problem to represent the left side? So we have 7, okay, and we're multiplying it by some number times a number, okay, and then we're adding that plus, or we can say plus 1. All right, so we know at some point we're going to be adding these on this side. On this side, we have 10 times a number, so 10 times some number or a number. All right, and we know that these two are held together by multiplication. Okay, even though the sign's not there, the coefficient and the variable, when they're side by side, they're held together by multiplication. So the easiest way, guys, is just to read through each scenario and see if you can find the one that could best represent this equation. So let's start with F. Brody ran at a constant rate of 7 miles per hour. Okay, so the 7 miles per hour sounds good so far. Okay, so far it could represent 7x. Okay, Candace ran at a constant rate of 10 miles per hour. All right, so now we're talking about Brody was the left side, Candace is the right side, a constant rate of 10 miles per hour. So far, that's good, but then it says started at 1 mile in front of the starting point. Well, there's no plus 1 on Candace's side, so therefore now we know that F is not our answer. Okay, because the plus 1 should be on the left side, so that should have went with Brody. Okay, so now let's move to G. Brody played a game where he scored 8 points per hour. All right, let's keep reading just in case. Candace played the game and scored 10 points per hour. So this 8 points per hour, that could have been represented as 8x. Candace played the game and scored 10 points per hour, so that could have been 10x. It says, what is x, the number of hours that Brody and Candace would each have to play the game? All right, well, guys, let's look at this. Let's just even look at Brody. We got 8 here. 8 is nowhere in our equation. All right, so we can automatically eliminate G. H, okay, let's look at H. Brody went to 2 different amusement parks. The first park charged $7 per hour and gave a 1% discount. Okay. Well, if I'm thinking about discount, okay, to me, that might think, well, something's being taken away, right? Because when you buy something at a discount, it's less than the original price. But and we have addition on this left side. So let's just keep reading just in case. The other park charged $10 per hour. Okay, so that could be good. Now, the reason why H, guys, is not the answer again is because they're using that terminology discount, and that should be represented by subtraction. So H is not our answer. So that only leaves J, but let's go ahead and keep reading. Let's just make sure. Brody rode his bicycle 2 different ways. The first day he rode 7 miles per hour. All right, so that's 7x. And started 1 mile from his house. All right, so that could indicate the plus 1. The second day, he started from his house and rode 10 miles per hour. Perfect, all right, so 10x. What is the x, the number of miles, perfect. So we have our 7x plus 1, and we got our 10x. So yes, J is our answer. So unfortunately, guys, there's no real trick to answering these questions. The best thing to do is just read each scenario. All right, let's look at example number 2. Which situation can be best represented by this equation? All right, so let's look at this equation. We have 8x plus 2 is equal to 12x. All right, so here we have this 8 times some number. All right, so we know we're looking for 8 times a number. All right, and now again, our operation that we're looking for with this is addition or plus. All right, so plus 2. Okay, on this side, all we have is 12 times some number times a number. All right, so let's look at our scenarios. Let's start with A. Grayson ran at a constant rate of 8 miles per hour. All right, that gives us that 8x that we want. Cadence ran at a constant rate of 12 miles per hour. All right, so we're going to put Grayson on the left here, and we have Cadence on the right, and that's 12 miles. All right, that's 12x, and started 2 miles in front. Well, the person who should have started 2 miles in front was Grayson, with the left side being 8 plus x, or 8x plus 2. So this one, unfortunately, not our answer. So again, we got to keep moving on. Let's move to B. Brian went to 2 different amusement parks. The first park charged $8 per hour and gave a 1% discount. All right, well, we got the $8 per hour, 8x, and gave a discount. That last problem we said discount. Again, when we're buying something for a discount, we're getting it at a lesser price. So, but we wanted to represent addition. Okay, so that doesn't go with Brian. So B is out. All right, let's look at C. Jesse played a game where he scored 10 points per hour. All right, we got 10x. Okay, and played a game and won 12. Well, and so again, let's look at Jesse, who's representing the left side. We got 10 points per hour. Unfortunately, guys, there is no 10 in my equation. Okay, no 10 in my equation. So again, C is not our answer, but let's look at D. Okay, Claire rode her bicycle on 2 different days. The first day she rode 8 miles per hour. All right, so there's our 8x. And started 2 miles from her house. Well, there's our plus 2. So far, so good. The second day she started from her house and rode 12 miles per hour. All right, so that's our right side of the equation. That's a check. 12, that would be 12x. All right, so yeah, D is our answer. All right, guys, go ahead and give it a shot with example 3. Again, it says use the equation shown to answer A minus B. So they give you this equation here, okay? And read each scenario, A and B, and determine if that could be an equation for this one. So you're going to read A and you're going to choose, you're going to either say yes or no. It could be the problem to this equation. And then you're going to use B and you're going to decide yes or no. So in the discussion, just put A, yes or no, and B, yes or no. All right? Good luck. One thing I do want to show you is your exit ticket for today. So again, just like on Tuesday, similar, just write these equations into words. I also added this word bank, and unlike Tuesday, I did put text box here, guys. So just go ahead in and type your answer, and you should be good to go. So I'm going to leave you with the screen at example 3. Make sure you answer this one. Again, read the scenario. It's either a yes or no. And hopefully I see you at the lives 9:30 and 2. Have a great day.